Please welcome Gabe Monroy, Lead Program Manager at Microsoft Azure and former Chief Technology Officer at Deis, along with Michelle Nurelli, Senior Software Engineer at Microsoft Azure and core maintainer of the Kubernetes Helm project.
Hey everyone, thanks for coming to our session today. I'm Michelle Nurelli, and I'm an engineer on the Azure Container Service team. I mostly work on open source tools that make Kubernetes easier to use, and we'll talk about some of those tools today. And I also run a special interest group that's focused on how to define and manage applications on Kubernetes. And this is Gabe. Gabe, tell us a little bit about yourself.
Hi everyone, I'm Gabe Monroy. I am the lead program manager for Microsoft Azure Container Service and former chief technology officer at Deis. Just recently joined Microsoft via the Deis acquisition. Excited to share a lot of what we have been working on in terms of open source over the last few weeks. And one of the things at Deis that we've been really excited about is trying to make containers easier to use with a specific focus around Kubernetes. So we're going to share a little bit about that today.
And we started this journey about 2 years ago. I remember when Gabe came up to me and said, "Hey, Michelle, what do you think about this Kubernetes thing?" And at the time, I was a few months into learning about containers and playing with Docker. But I remember thinking, Kubernetes is a really clean way to orchestrate containers. And I was personally impressed by some of the powerful abstractions that it provided for things like managing your cluster and rolling out new versions of your software. And her whole team was pretty sold on the idea that Kubernetes was the right abstraction layer for these kinds of things. So then it came time to really test it out and hit the ground running with real-life applications. But to run an application in Kubernetes, we needed to define and create multiple Kubernetes resources. So for example, for a simple app, you might need a pod. And inside of that pod, you'll run your container or a group of containers that are tightly coupled for your application. You'll also probably define a Kubernetes deployment resource type because deployments help with managing rollouts of different versions of your application. And that's a pretty powerful feature as well as a best practice. So when you update your application, the deployment you define will do things like scale down your old version gracefully and scale new pods up with your new containers for your updated application. And the last piece is defining a service. A service in Kubernetes defines how things inside of your cluster communicate with your application, as well as things outside of your cluster like the rest of the world and how that communicates with your application. So right off the bat, we're defining multiple Kubernetes resources to make our applications work. And the process of managing those resources was becoming a really tedious task. We were finding that we really wanted a way to install this group of files or a package of files which had related Kubernetes resources in them. And we wanted a way to keep track of those resources and do things like upgrade, rollback, and delete on this group of installed resources. Basically, we wanted to treat these resources in Kubernetes like one logical unit. So we realized what we need was a package manager for Kubernetes, something that would make it easy to install and manage a group of Kubernetes resource files. We looked around and realized that we wanted an apt-get or yum install or homebrew-like experience for Kubernetes. These are common package managers for operating systems, and they make it easy to install software onto your computer. So why not something like that for Kubernetes? So we built a tool called Helm. In Helm, a package is a chart. It's called a chart. And a chart is an application definition. It consists of some metadata. It also has the Kubernetes resource definitions that you'll need for your chart. This is the bulk of the actual chart. These resource definitions can be templated or non-templated. If they are templated, the configuration will live inside of the chart as well. And the last piece is documentation. This documentation is important for people who are consuming your chart to understand what to do with it. And charts live in chart repositories. This is a basic HTTP web server with an index.yaml file in the root that gives you some metadata about how to find your actual chart. And so a chart is one of the three basic core components of Helm. And like we talked about before, the chart is the expert-built recipe for installing an application. The values are user-supplied configuration. Now, this config can live inside of your chart, but you can also override it with a file that has your configuration outside of the chart. And a release is an instance of a chart and a values file that gets deployed into your Kubernetes cluster. So release equals chart plus values. Chart is the recipe, values is some extra sauce that you add to your application, some knobs that you can twist and turn. And the release in the Kubernetes cluster is the thing that is what you're going to roll back and upgrade and delete and manage. So you might be wondering, how do you get started with Helm? Once you've got the binary, the first command to run is helm init. Helm init does two things. It configures your local machine to work with Helm, and it also installs a server-side component called Tiller in your Kubernetes cluster. Now, once you run a Helm init, you can actually use kubectl, which is the Kubernetes command line interface tool, to see that Tiller is running in your Kubernetes cluster in the kubesystem namespace. So you might do commands like kubectl get pods -namespace kubesystem, and you'll see that Tiller is at the bottom there and it's running, and that's when you know you're ready to go. This should take a few seconds. It's a really smooth process. So let's get into it and see what Helm has to offer. All right, the first thing we're going to do is see what a basic chart looks like. So to do that, you can scaffold out a brand new chart with whatever name you want. I'll call this my chart. So if I do an ls on my chart, we can see the basic structure that we get. A chart usually has a chart.yaml file. This is the metadata that I was referring to before. It has a templates directory. This is the bulk of where the bulk of your chart lives. This is going to house the Kubernetes resource files. And the values.yaml file is the default configuration for your chart. The charts directory inside of your chart can help you or allow you to vendor in other charts that are dependencies for your chart. All right, so now that we know what a chart looks and feels like, let's see if we can find one and install it into our cluster. So to do that, I'll use the Helm search command. And I'll search for Redis. So here we see we have a stable/Redis chart. Stable is the chart repository that the Redis chart, in this case, lives in. A chart is always namespaced by the chart repository that it lives in, so that you avoid naming conflicts. Let's see what versions of Redis we have available. We'll do that using the -l flag to list out the versions. And let's go ahead and install 0.5.0 so we can see what an upgrade looks like. And you do that using the Helm install command, but if you want to see what the default configuration looks like, you can actually use a different command called Helm inspect. Helm inspect allows you to fetch the charts, just the default configuration, and display that in your terminal. So I'll do a Helm inspect stable Redis for the version, let's say 0.5.0. And this is all the default configuration. So let's check out this image here. The image that we're going to run from this chart is 3.2.8. And that's good to note because when we bump it up, this is the thing that's going to change. So let's go ahead and install that chart into our cluster. So several things happened here. Let's go back and kind of dissect this output. Here we have a name. This is a randomly generated name for your release. So when you did an install, Helm created a release and saved it in your cluster. The name of this release is Old-Fashioned Goat. You can totally override the random name generator, but I learn a lot of vocabulary from the random release names, and they're just more fun, so I recommend them. You also have some metadata here. The next section is the resources section. These are the actual Kubernetes resources that got deployed in your cluster from your chart, and their current status. And the last piece is the notes section. This is like post-installation instructions for your chart. This is something that the chart author defines, and it gives you some steps to make sure everything's running fine, and kind of gives you guidance on what you can do next or what you might need to install next, and how to play with your chart installation. It's really nice to have. Let's drop down into our cluster and see what's going on there. So here I have a Redis pod, and that's running. And we'll just describe that to make sure we have the right image. So we do that using the kubectl describe command. So if we scroll up here, we'll see that we're running Redis 3.2.8-R1 from the Bitnami org, and everything seems to be fine. So no errors, we're good to go. Now we're gonna see what a Helm upgrade looks like or feels like. So let's upgrade to the latest version of Redis. If I do a Helm upgrade command and pass in the release name, which was Old-Fashioned Goat.
Old-Fashioned Goat, very distinguished.
Love Old-Fashioned Goats. Okay, so we'll Helm upgrade and this release, and we'll do the stable Redis version that's at the latest version. So you don't actually have to pass in the version flag for this. You can just pass in the just stable Redis and it'll go to the latest. More stuff happened. So this is the same output. Every time you do an upgrade, you'll get this kind of output. And it's the same output that you'll get also in the Helm status command. You have metadata again, the resources that were deployed, and the notes section. Let's drop down and see what's going on in our cluster. So here we have a pod running. Let's make sure that the image that's running is something different than 3.2.8-R1. Describe command. Great, and now we have a Redis version at 3.2.9-R2. So it worked.
Wonderful.
And some other commands you can use are Helm list. Helm list lists the releases that you have. We can also delete Old-Fashioned Goat, but I hate to do that, so it's a good name. And if we do that and drop back down into our cluster, then we'll see that no resources are found. So we're good to go. So let's recap the basics. Helm is a package manager for Kubernetes. A chart is a Kubernetes package. A release is an installation of a chart and its values in your Kubernetes cluster. And Helm is a little bit more than just a package manager because it also manages the life cycle of your application. And Helm is a good tool for operators to manage the lifecycle of the application, but onboarding developers to Kubernetes is still really hard because you have to learn lots of things before you can even begin to be productive deploying applications on Kubernetes. Docker and Kubernetes concepts take some time to learn and master, and that's just the reality of it. Right, Gabe?
That's right, and this is something we've been very passionate about since joining the Azure Container Service team. During Michelle's keynote at this year's KubeCon in Berlin, she talked about how Kubernetes is still too hard to use for developers. And one example she gave is Ruby on Rails. the web framework which famously promises to help you build a blog in 15 minutes. As Michelle put it, we need Rails for Kubernetes.
Absolutely.
Yeah, and she's right. So what might that look like? Well, I think it's helpful to reflect on the software delivery process for modern container-based applications. So, if you break this process down into 3 distinct steps, you really have as the first step what I call code to commit, or what we at Microsoft call the inner loop. This is while developers are hacking on code, but before they commit and push that code to version control. The second step is commit to artifact. Now, for these modern applications, after developers push their code, typically a continuous integration system will pick up those changes, build container images, test them, and publish them to a container registry where the final artifacts are stored. Now, the last step is artifact to deployment. And as artifacts are updated in this way, they're continuously deployed out to staging and production environments with whatever human gating and testing is required between those environments. Now, when it comes to Docker and Kubernetes, many developers get tripped up right away during the inner loop process, as Docker and Kubernetes concepts begin to enter the picture. Some common questions we hear when we're speaking with developers, Michelle and I can both relate to this. Do I need Docker installed? How do I write a Docker file? How do I build a container image? Where do I push my image once I'm done? And on the Kubernetes front, do I need Kubernetes installed? How do I write a Kubernetes manifest? How do I test my app to make sure it works inside of a running Kubernetes environment? Now, the answers are out there if you look hard enough, but what if developers didn't have to ask those questions at all? So I'd like to introduce Draft from the Azure Containers team. Draft makes it really easy to build applications that run on Kubernetes. Draft targets this inner loop portion of the developer's workflow as they're hacking on code, but before that code is committed to version control. Let's go take a look at what this looks like. So if we flip over to my laptop, so what I have here is a very simple application, and actually you can see this is a very straightforward Python Flask application, and the idea is it's just going to print out hello draft when we're done. But one of the things you'll note is inside of this repo, and actually we can look at this inside of VS Code, you'll see that there is nothing here that is specific to Kubernetes. There's no Docker files, there's no Kubernetes manifest, there's no Helm charts, nothing that would describe how to actually run this thing. So if you're a developer and you've been told by your software team that you need to get this thing running inside Kubernetes, what do? Well, with Draft, it's as simple as this. Type in draft create. What Draft is going to do is it's going to actually detect what type of language you wrote inside of the source tree. And it's going to do some interesting things like scaffolding out a Docker file, a Helm chart, and some configuration for the draft binary. This effectively containerizes your application via scaffolding and writes it out into your source tree. So from this point, all you have to do as a developer is type in draft up. And what draft up does is it will take your source code, ship it to the remote Kubernetes cluster, build everything in the remote cluster, make sure everything is, all the images are available, and then take that Helm chart that's sort of the default values, for a Python application, get that running via a Helm release inside the cluster, and then automatically expose it via something called Kubernetes ingress, which is, you can see published at this URL here. We've got filled tiger. We happen to use the same name generator as they do in the Helm project. So now if I open up filled tiger, we can see hello draft is being promoted. Now, this is interesting, okay? So we containerize the application, we got it working, but what if the application is not working right yet? Right? What if we're not done yet? Well, let's go make a change. So let's go into our Visual Studio code editor here, and let's change this from hello draft to hello OpenDev. And I'll hit save. And the moment I hit save, what's going to happen is the draft command is going to be constantly looking for file changes on the local file system. And when it detects a change, it will automatically ship that change up to the cluster, rebuild all of the images, and push out an updated Helm release that will be available in seconds so that you can actually see what your changes look like live. Again, keeping in mind that this is before you're ready to commit while you're still sort of hacking on the application. So if we go back to our browser and we hit refresh, we can see hello OpenDev. So this is making it incredibly easy. As you can see, the developer didn't really have to understand anything about Docker or Kubernetes to get started. And now when they're ready at this point, they can commit their changes, push them up to source control, and move on from there. So if we flip back to the slides, we can, just for a recap on how draft works, so you can see, step one is draft create, which is going to do the scaffolding, detect the application, write out the Docker file and necessary Helm charts and metadata into your repository. Step two is type in draft up to trigger this sort of inner loop watcher that is going to sort of monitor your IDE and make sure that any changes are going to be automatically reflected in the Kubernetes runtime environment. And step three is do what developers do best. Hack away, get to work on your application, make sure that it's doing what you need it to do. And once you're done, you can commit those changes, push them up to source control where a continuous integration system can take over. So those are the three steps. Draft, again, making it incredibly easy to get started with Kubernetes. We really want you to try this out on Azure Container Service. We have a lot of great documentation online about how to set up draft specifically for Azure with Azure Container Service, Azure Container Registry, and really get going quickly.
Yeah, and if you'd like to get started and help us out and get hacking, then those tools that we just showed, they're open source, so you're welcome to pick up an issue or submit an issue and submit feedback. We very much welcome that.
Great. Thanks, everyone, for attending today. This has been a wonderful event. We look forward to working with you on open source in the future.
Thank you.